Hello everyone. Today I was looking at one of the projects that I have in my dynamics class, which is basically animating this simple mechanism here. So here you have this horizontal slider that has this pin or point P, and the point P is constrained to move in this basically quarter circle here with the radius of 300 mil centered at origin. And so it can move left and right. That gives it that degree of freedom. And this slider here is moving on this horizontal guide, which itself is moving on this vertical guide up and down through this other slider here. And the position Y of the slider, which is also for point P, is controlled. And so one of the things I ask in my class is, could you animate this mechanism here as this point P goes from this top point here, Y of around 300, down here to Y of about 0? Can you animate this mechanism? But I asked him to do it in MATLAB. And then I thought to myself, well, if you want to do it in Python, how would you do that, right? Because MATLAB, I have videos for MATLAB animation. You can watch it under my playlist MATLAB, and I explained how you can update the plot and create the animation effect. And I said, well, what would you do if you want to do it in Python? Because many people use Python. Python is not proprietary, it's free. So how would you do it in Python? And I said to myself, let's make a video about it. So here is making an animation in Python by updating a plot in a repetitive manner, a recursive manner. So here, what you need is, you need NumPy for creating vectors, and you need matplotlib for creating plots. And also from matplotlib animation, you need two things. One is called FuncAnimation. This is the one that you can create animations with. And here I want to show you one extra thing as a bonus, and that is how to create a movie out of that animation, an AVI movie that, let's say, you can import into your PowerPoint presentation or something. Because if you watched my animation video in MATLAB, you see MATLAB has this command video writer, which you can take snapshots of your screen, basically, of the window that is open, and convert it to an AVI movie. So here I want to do a similar thing. Okay, so this is the code. And here you see the radius is defined, and also have defined a speed for changing Y, okay, because I want to include some speed in this. As I said, this Y here is under your control, the way that this Y is changing. So the parameter that I have, the control that I have here, I fix this Y dot at 300 mils per second, okay? So this is under my control, and that's what you can see over this. And I use the NumPy linspace, and I go anywhere from a little bit over 0 to a little bit less than 300 points, and create the Y values. And then I'll divide the second value in Y values, which is basically like the second number. I divide it by this Y dot to give me time. So dt is what is here like the time step between these updates on the Y. And we calculate the x values for each y value. Now, I also calculated, I wanted to also calculate velocity and accelerations of that particle P at any y value too. But here I just decided to change it and just do the animation part and not calculate the velocity and acceleration of the particle for extra plots or extra information. So here you see that the equation of the circle is, of course, x squared plus y squared equal r squared. So x is r squared minus y squared here. And I do it for each y in the y value, okay? So here we calculate the x for each one of those values in y, and then we start the figure and axis for the animation. So I use the PL subplots, figure and axis, and then I use the x limit and y limit, and then x label and y label, and then title, and then what we start doing the rest of the stuff. Now here if you can see, the quarter circle is the part that is stationary and it does not need to be updated. So what I do is I create theta from 0 to pi over 2, 100 data points, and then r cosine and r sine theta are x and y, and then I use the ax dot plot, right, and pass it xc and yc one time with black color and a line width of 10, and other times with white and line width of 4. So these two together will create basically this slot here. So it is going to fill these areas with black and these areas in between with white. So it is going to create this slot for you. Then here you initialize the other elements of the plot. What are they? Well, they are basically, you have one element here for this horizontal slider. You have a line for this horizontal guide. You have one for the vertical slider. You have one for the vertical element. And you have a point for P, a circle. So we need to update these, although this vertical line can also be done outside the loop, and since it does not get updated. So here you see vertical bar is x plot and no data right now for x and y, and it is going to be color blue, line with 6, horizontal bar color green, line with 6, no data, slider 1, slider 2, and point P. They are also done, you can see, with black squares, right? The two sliders are black squares, and then point P is a red circle, right? So also we fill it with red as well, so it's completely filled circle. Now, when you want to create animation in Python, you need to define a function. A function here, we call it update function. And this update function is used in this built-in FuncAnimation function. And when you call this FuncAnimation to create animation for you, you need to give it a figure, which here we have already created. Okay, so that's the figure name or number. You need to give it the update function, and you need to give it the range of the frames and the interval, which is used like a pause command in MATLAB to slow down the animation or controls the speed of the animation. So what does this update function do? This update function basically will do what? It receives II, which is the frame number, okay? So input to the update function is the frame number, II. What is the output of that? It outputs the data points for these elements. If you look, when we started these elements of the animation, slider 1, 2, horizontal, vertical bar, and point P, we started with no data, empty. So the goal of this update is to return these elements, as you can see, but with the X and Y data updated for each frame. So I pass to it the frame number II, okay, and II is already taken from the Y values. So II is a vector. That is like 1, 2, 3 all the way to the length of Y values, correct? Or 0, 1 all the way. And Y are those values. So II's are the indices. And as I said, they start from 0 to n, right? And here you see that once you get the frame number, you read that ith element of Y values, you call it Y, you find X through the square root of R squared minus Y squared. And once you have X and Y, you can pass it to slider number what? Slider number 2. The data for slider 2 are X and Y. The data for slider 1 is R and Y. So what are these? Slider 1 is this guy. This is a slider 1, because if you look at it, the Y of it is Y, but the X of it is R. So when it says X of it is R, means that basically this vertical bar is going to start right here at the end of this quarter circle. It doesn't have this extra offset. Okay, If you want, you can give it an extra offset here, but here in this animation, we avoided that extra offset. So we plotted right at R and Y, but slider 2 is X and Y, and this is what? This is a slider number 2, where the location for it is clearly what? X and Y. And then the horizontal bar, if you look at it, the X values for the two endpoints of it are 0 and R, and the Y's are Y and Y. So it means one end of it is 0 and Y, the other end of it is R and Y, and that is obvious from this picture that if you consider one endpoint here and one endpoint there, clearly, right, or actually one endpoint should be, let me maximize this and clean up a little bit. So one endpoint of it is here. The other endpoint of it is there, right? Okay, let's go back and look. So 0 and Y, R and Y. So X of 0, Y of Y. So actually, no, it's here. X of 0, Y of Y, and then X of R and Y of Y. So it comes here. So you're going to draw a horizontal bar just like that, not this point. So your horizontal bar is going to go all the way from left to right. Okay, like that. From point 0 and Y, which is here, to point R and Y, which is there. And then the vertical bar goes from X of R and Y of 0 to Y, X of R and Y of R. And clearly, those are these 2 points. This point here and this point. Okay, and clearly you see that the data for the vertical bar does not change. So if you want, you can get the vertical bar out of this return function or update function, because the update function, because it does not need to get updated. And point P, of course, is at location X and Y as well. Also, we set up the title for the axis, and the title returns the Y value for you. So your title of your plot will also get updated, and it shows the current Y value as the point P moves. It shows the Y of point P. And you see the returns of this function are what? Are those function handles, are those graphic plot handles, vertical bar, horizontal bar, the ones that are used here. Clearly, these are what? These are what in MATLAB we call them function handles. Here it's called plot elements. That's the same thing. So that's what this update function does. We give it the figure, and here we say frames range from 0 to length of Y value and 5. What does that mean? Means you don't need to show each and every one of the frame of that animation. Jump by 5 frames at a time. So what you want to show me is frame 0, then frame 5, frame 10, frame 15, and so on and so forth. So do not show all the frames, skip the frames 5 at a time to speed up the animation. And if you want to slow down the animation, you can use the interval command here, which is like the pause in MATLAB. So whatever number you pass to it, it is going to do a pause, a delay in milliseconds. So here your dt, if you look at it, your dt is about 1 over 300. This dt is about 1 over 300. So you multiply it by 100, that's 1 over 3. So it's a very small thing, 1 over 3 milliseconds. It's a very short interval. The bigger you make this, the slower the animation becomes. So this interval controls the speed of the animation. So here, this creates the animation for you and shows the animation. And then if you want to save these frames of animation to an AVI movie, you need to use what? FFMpeg writer, which here it's coming from the Matplotlib animation. Okay, so once you download this, needs to be downloaded. Okay, you need to download this from its website and install it and add it to the path of Windows. Once you do that, then you can call it to create an object for you here. Here, the goal of this object is to write the AVI movie, and the frame per second is 10. You can give it some metadata if you want, you don't have to. And then the bit rate for the video, which is here 1800. So you do the setup for the writer object, and then you say animation.save. So your animation object has a method called .save, and then you give it a name. Here I call it particle underscore motion.avi, and then you say the writer for it is this writer that I defined above that has those properties: 1800, 10 frames per second, and the metadata is the artist is me. So I am the person that made this video. Okay, and do that, and also here you show the animation. Okay, and if you want, you can bring this show animation, I assume, up here too. So show the animation and then save the animation to an AVI movie. Okay, so this is the file. Let's go ahead and run it. Here we go. The green is horizontal slider, the blue is vertical slider, or the bar, sorry, and then the two black squares are the sliders, and the red point is the particle P. And here you can see that this is your quarter circle slot, and the y of the point gets what? Gets updated. You start from 300 and gradually go to from 0. You start from y of 0 and gradually go up to about 300. Okay, there we go. Yes. So this is your animation, and once you close the animation, it should be writing an AVI movie to your what? To your local drive, which here I have it. Okay, here is that AVI movie that I opened with Media Player, as you can see. And you see it's called Particle Motion AVI. And clearly you see that it's written to an external file, and now I can easily import it anywhere that I want. There we go, right? So here is the saved AVI movie. So hopefully this video showed you something useful, and that is how to use the FuncAnimation from Matplotlib Animation to create animations by updating a plot, where the update function returns the updated handles with the updated data, and also use the FFmpeg writer to create an AVI movie out of what? Out of this animation. And if you're wondering where I downloaded this FFmpeg writer, here is the page, ffmpegwriter.org, download HTML. You come here. If you have Windows like me, you click on Windows. It gives you these two pages to download, and if you go, let's say, on this top one, here it shows you how to basically download it. And the way I did it, I used this one. I used the winget install FFmpeg, and I type that command in the command window. It downloads it and basically installs it for you. And then you also need to go and add this FFmpeg to your path. For that, you need to go to the computer setting, and then go to the advanced system setting, and then go here to environment variables, find this path, and then say edit, and then here this is the path that I added. So I didn't have this one, so for that you say new, and then here is the address of what? Here is the address of the bin folder for FFmpeg writer. So when that command window installs FFmpeg writer for you, you can find the location of it and find the folder, the bin folder, and find the address of that and add it here under what? Under environment variables for the path. And once you okay all of this, now your Python here, my Python basically code can find it when you do the import. It can find it and it can use it. Thank you so much. I'll see you in the next video.